me see. I think most of you are done already. Okay. Can we take a look together on the next page? And so if you didn't know, you already finished about 80% of the content already. Every single question they change here, change there is the same. And so right now we are going forward to something a bit special. We're going a bit deeper to one point. We call it the titration graph, right? We call it the titration graph here. So before we talk about titration graph on checkpoint number 5, can I fast forward you to part 2 first, the next page? I'd like to highlight with you a little bit of titration graph. This is actually the last category. Then later you will see I will combine all the questions together and you start to see how the question is being asked. The question they ask is very standard one. Just stick to the formula, you'll find it is very manageable. So sketching of titration graph. Now I understand some of you are new to the technique. But trust me, it's not difficult. It's not difficult. It's a very easy way to sketch it. For those of you who always find sketching titration graph is difficult, maybe you want to follow this technique for the moment, temporarily forget what you learned. So let's take a look here. Now, first of all, when you sketch a titration graph, it's very important to know 2 things. First, you must know who is in the conical flux, because the one in the conical flux is the one that you measure the pH. Not the one in the burette. The one in the burette, you never measure the pH. You only measure the one in the conical flux for the pH. So it's very important to know who is in the conical flux. Hey, but the good news is, nowadays, most of the questions for A-level, they will tell you who is in the conical flux. So you don't have to worry about it. In the past, they don't tell you, but now they tell you. So that's good news. Okay, so the one in the conical flux is important. Now I tell you, hey, this is in the conical flux. Now, what does it mean? That means if I measure the pH, initially will be low pH. I mean, that's important, right? If you put the base, the pH should be high, you know. You put the acid, pH should be low. So remember, the who is in the conical flux plays a very critical role. Next, who is in the burette? Now, NaOH is the burette here. So that means you add a base into the conical flux. What will happen to the pH value as your base neutralizes the acid? It will rise up. So you know whether it go up or whether it go down. Okay, so now we know conical flux is important. Who is in the burette is important. Okay, then we need to know the axis. Now the axis here, you see this is the x-axis. X-axis represents the volume of the titrant. Now, titrant is a term I need you to be familiar with. Titrant is from the burette. So remember, titrant is from the burette. So therefore, if whatever volume I add from the burette represent on the x-axis, right? This is all from the burette. How much I added in. Then followed by the one of the pH value of the conical flux is on the y-axis. Okay, so be aware, y-axis is the conical flux. X-axis is in the burette. Okay, so now we understand how you read it. What is a technique I should use to draw the graph? Okay, so we use a very interesting technique here. I call this technique as I eat banana every day. Not difficult to remember. Let me show you how is it done. What does the word I represent? Your initial pH. So whenever you think of drawing titration graph, think of the word I, initial pH. What is your initial pH? Initially, if you have only weak acid in the conical flux, what do you use? The weak acid formula. We just did it. What happened? You have a weak base in the conical flux. Use the weak base formula. That is the I here, one compound. Second, equivalence point. Now, equivalence point means the point of neutralization. We'll discuss that. All your acid, all your alkaline is fully reacted. So this is the point whereby there's a drastic increase in value. Later, we will see at more real examples, but just keep in mind it's a drastic increase. Now, there's only 2 different types of neutralization. First one, if I have strong acid and weak base react. SA is strong acid, WB is weak base. Strong acid and weak base react, you will form a salt first. Acid and base give you a salt. How do you know which one is acidic? How do you know which one is a basic? Very simple. The acidic or basic is tagged along with the strong. Think of like a tug of war. Strong, a stronger side and a weaker side. Who will win? The stronger side. So the stronger side will win, the acidic salt. Weak acid and strong